technically, we're all just meat. Yeah, you could say that what makes us human is our emotions, our thoughts, our memories, but physically, we're not all that different from this. We're used to thinking of meat as the muscle tissue that people cook and eat, but the fact is you can eat that stuff raw. A chicken breast or a steak or a pork chop is tender enough that it doesn't need cooking. What does need cooking is all of the connective tissue that's in and around the muscle and gets in the way of our meal. So one of the main reasons humans began to roast and boil and bake meat in the first place was to break down those connective tissues that we can't chew so we could get the meat. Now you might have noticed that connective tissues kind of seem like a grab bag of materials that don't really fit in other groups. Our muscle, nervous, and epithelial tissue types are more uniform, more obviously grouped together. Sometimes our connective tissues just seem like the leftovers you throw in the stew pot. But appearances are deceiving, and our inability as a species to tolerate these tissues in our food is just one reminder that no matter how different tendon, bone, or a hunk of fat may appear, they are indeed very closely related. They all spring from the same embryonic cells, and their structures are dominated not by cells, but by an extracellular matrix full of fibers. And it's those fibers that have given humans the most trouble in our meat-eating history. It wasn't until we figured out how to cook this stuff that we were able to denature or change the natural structure of those protein fibers so that they became soft and pliable. Take a chicken, for example. You couldn't just pull the skin off a living bird. Like, ethically you couldn't do that, but also you probably couldn't. Its living skin is anchored by connective tissue that's full of collagen fibers, but if you roast that chicken and break apart that collagen, suddenly the skin just peels right off with no effort at all. So connective tissues, as evidenced by this mess here, are good reminders of how sometimes things are more similar than they appear. They're also delicious, if you're into that. So we know what our connective tissues have in common, and we know that we've got 4 different types, but what do they look like, what do they do, and where are they found, both in your butcher shop and on your body? Perhaps your most diverse type is your classic connective tissue proper. It comes in both loose and dense subclasses based on how many fibers it has in its ground substance. Pull on the back of your hand. See that fleshy tent there? That's one example of loose connective tissue. There's a lot of ground substance in here, and the elastin fibers help it snap back into place, while the collagen helps anchor it so you can't, like, snag your skin on a zipper and watch it just fly off. But try pulling on your Achilles tendon, or these wing tendons here, and there isn't a lot of give. That's because a tendon is an example of dense connective tissue with a lot more collagen. You could chew and chew and chew on a collagen-dense tendon and never get anywhere. That's why butchers trim off most dense connective tissue before selling cuts of meat. So loose connective tissues have fewer fibers and more cells and more ground substance. Areolar tissue is the most common loose connective tissue you have found all over your body, just under your epithelial tissue and wrapped around your organs. It's got a loose, random arrangement of fibers with just a few fibroblast cells that make those fibers. If you look at it under a microscope, you'll see that its most obvious feature is that it looks like it has a lot of open space in it. This makes areolar tissue great at holding the watery, salty ground substance that surrounding tissues draw from. Your adipose tissue, meanwhile, is your fat tissue, the loose connective tissue that's in here. Rather than being mostly ground substance, this one is mostly cells, adipocytes, which store lipids for later use, insulate the body against heat loss, and grow pot bellies and love handles. The average person's weight is about 18% adipose tissue, and it's those fat stores that keep us alive when food is scarce. With no fat stores, you'd die within a few days of your last sandwich. Reticular tissue is like areolar tissue, but with a woven mass of reticular fibers rather than collagen and elastin fibers, hence the name. This tissue provides the soft internal framework, or stroma, of the spleen, lymph nodes, and bone marrow, and it supports lots of developing blood cells. Just as your areolar tissue is a kind of sponge for watery ground substance, your reticular tissue is what holds your blood in place in many of your organs. Really, all of these loose connective tissue proper types share an airy dispersal of fibers, which is why they're easier to eat after cooking, and why you can pull cooked chicken skin apart. On the other hand, you can't easily rip a tendon or a ligament in two, or even chew it, because it's made of that dense, regular tissue full of tight bundles of collagen fibers all running parallel. You can see how neat and smooth a slide sample looks under a scope, the fibers being those white, flexible structures. They provide great resistance to tension when that tension is exerted in one direction. That's why you find this tissue in your tendons, which connect muscle to bone or other muscle, and your ligaments, which bind bones together together anywhere you got a joint. But what if those collagen fibers aren't all stacked regularly in rows? Then it forms dense, irregular tissue, whose fibers are thicker and arranged erratically. It's found wherever tension might be exerted in lots of different directions, like the leathery dermis underlying your skin. And finally, your body has places that require more elasticity than rigidity, like say around your joints. That's where you'll find dense, elastic tissue. For example, connecting your vertebra so that your spine can curve and twist. Some of our largest artery walls are made of this stretchy, elastic tissue too, which provides both support and flexibility. From fat to tendons, connective tissue proper is the most diverse group in this tissue family. But for the last few minutes, you've also been watching a different type of connective tissue bob up and down as I talk. Cartilage. Cartilage doesn't have any blood or nerves, and it stands up against both tension and compression pretty well. It's that whitish gristle you see at the end of pork ribs or chicken wings in your grocer's freezer, and it's another thing that you're not going to have much luck chewing. Hyaline cartilage is your most common type. It's kind of glassy looking and provides pliable support. It connects your ribs to your sternum and keeps the tip of your nose all perky. Its ground substance is rich with those sticky, starchy proteoglycans, and although it has collagen fibers, when you look at it under a scope, you can't really see them. Instead, the tissue looks glassy, hence the name hyaline, meaning glassy or transparent. Elastic cartilage is very similar to hyaline, but with more elastic fibers that are easier to see, and it's found in places where strength and stretchability are needed, like it's why I can pull on my ear without it ripping off. And just as your body needs firm parts and stretchy parts, it also needs shock absorbers. That's where your fibrocartilage comes in. It's dominated by thick fibers of collagen and is good at withstanding lots of pressure, so it makes up the discs between your vertebra and your knee joints where it keeps your bones from grinding together. And speaking of bones, although you might not think of something so hard and durable as living tissue, bones definitely are. The word bone can refer to an entire organ, like your femur or scapula, or just bone tissue. And that bone, or osseous tissue, is just calcified connective tissue, perfect for supporting and protecting your body's various structures. Spongy bone tissue is typically found in the heads of long bones and in the inner layer of flat bones like the sternum. This spongy tissue is strong but porous, even to the naked eye, and it uses this extra room to make and store bone marrow. Compact bone tissue, on the other hand, is quite dense with no visible spaces. It forms the external layer of your bones and stores calcium for bone cells to use to make more tissue. Now, if bone doesn't conjure up your traditional image of a tissue, blood probably doesn't either. I mean, it doesn't seem to connect things or lend support, and yet blood is our fourth type of connective tissue. And when you think about it, it clearly does connect distant parts of your body and provide some rigidity to other parts. Just like other connective tissues, blood develops from mesenchyme and is made up of cells surrounded by an extracellular non-living matrix. In this case, the ground substance is your blood plasma, which has protein fibers floating around in it. Your blood's main job, of course, is delivering goods. It transports cells and nutrients and hormones and wastes and all kinds of other stuff, keeping all the parts of your body connected in the process. Most of your blood cells are erythrocytes, or your famous red blood cells that zoom around carrying oxygen and carbon dioxide through your body. You've also got larger infection-fighting white blood cells, or leukocytes, in the mix, and your platelets, the small cell fragments needed for blood clotting so that a paper cut doesn't bleed you dry. Unlike other connective tissues, it doesn't really have what you would call fibers, but instead has a bunch of protein dissolved in the plasma, and those protein molecules will form fiber-like structures when your blood needs to clot. So, you take your four primary types of tissues and all of the subtypes of each that's taken us weeks to explore, and you can probably see how they can come together in many, many combinations to form all of your body's organs. And just like that chaotic cafeteria packed with middle schoolers, we'd be hopeless messes without our hierarchy of organization, our inner and outer boundaries, and the ability of our systems to communicate with each other. That is what our tissues do for us, and we wouldn't exist without them. Today, we wrapped up our 4-episode series on tissues with a survey of the subgroups of loose and dense connective tissue, including areolar, adipose, reticular, tendons, ligaments, dense irregular, and dense elastic tissue. We also talked about the 3 cartilage types, spongy and compact bone connective tissue, and how and why our blood is also a connective tissue type. Thanks to all of you for watching, especially to our Subbable subscribers who make Crash Course possible to themselves and also to the rest of the world. To find out how you can become a supporter, you can go to Subbable.com, and don't forget to go to YouTube.com/CrashCourse and subscribe. This episode was written by Kathleen Yale, the script was edited by Blake DiPestino, and our consultant is Dr. Brandon Jackson. It was directed by Nicholas Jenkins and Michael Aranda, and our graphics team is Thought Cafe.